I'm an highway design engineer and I have been designing roads for over 5 years now. I'll be taking you through the geometric design of a typical road. And in today's tutorial, we'll be looking at the survey data. We'll also look at how to import the data into Civil 3D, would create the surface and also create alignment. We would look into the profile, the horizontal profile, and where I'll be going into details of how to go about all of these items. And in my next video, I'll be going into the development of sections and every other aspect that we will be going through next in the next video. But for today, we'll be starting with the survey data. Right on my screen now is a typical survey data. The survey data are taken by the surveyors on site, and they try to take the points of various features that are on a proposed road. So this data is gotten in the coordinates x and y, which you can call the easting and the northing. So here I have 5 columns. This is called the point number. This is the easting. This is the northing. This is the elevation, which can be recognized as Z. And this is the description, which is denoted as D. So once the raw data is taken from the instrument, maybe with the use of a total station or a differential GPS, these raw data are arranged in this order and they are stored in CSV file, in the CSV format. You know, the Civil 3D is compatible with the CSV format and also the text format. But in this video, I'll be showing you how to import the data from the Excel file into the Civil 3D using the CSV file. Now, once you are able to arrange your data in this way, you would have to take note of the arrangement and you will use the same format while importing the data into Civil 3D. So here I have my format as P E N Z D, which is the point number, the easting, the northing, the elevation, and the description. So we're going to make use of this when we get to the AutoCAD. Now, you must also take note there is this CSV has to be in comma delimited. We have the CSV UTF 08. You will not store it in that format, so just store it in CSV comma delimited. So now once you are done with arranging it this way, you can see there are 529 points taken. So once you are done, make sure that close you close the file. If you do not close the file, you might not see the file being indicated green on the Civil 3D. So let's go to the Autodesk Civil 3D. All right. Now, this is the Autodesk Civil 3D. I'm going to open a new page. All right. Now, if you look at this workspace, you will see that I am in the Civil 3D environment. You must ensure that you are in the Civil 3D environment. There are other environments here. You have the drafting and the annotation. You have the 3D modeling and so on. So you need to ensure that you put this on the Civil 3D environment. So having done that, it's also important for you to know the type of AutoCAD you are using, either in Matrix or in Imperial. I am using the Matrix format, which is the British SIE unit, and so we're going to be setting up the projection of the coordinates of this of the data. So you have to take note of where the data is being taken from. If you are in Nigeria or you are in the UK, you need to set up your projection so as to be able to find the file easily. Now, we'll start up by coming to drawing utilities, and then once you are in drawing utilities, you come to the drawing settings. Now, on the drawing settings, I said earlier that I am using the metric. So by default, the the units are in meters and degrees. So you can decide to change the scale as you desire, but this is where you need to come to. So you need to do your datum and projection. So I am actually work the file was taken from Sierra Leone. The data was taken in Sierra Leone, so I have to pick Sierra Leone, and you need to identify the zone of your coordinate system. So the zone is at 29N north. So I will apply and say OK. So also you will need to set your units to so you type on your keyboard UN and then click on the unit, and you have your lengths are in decimal. You have the engineering, you have the architecture, the fractional. Just keep it at decimal if you're working with metrics. So you can either decide to make it degree, minutes, and seconds, but I want to work with decimal degrees. So and then I change my position to 3 decimal places. You leave for me. I leave it as anti-clockwise, and then I change the direction to north, and then I click OK. So with this, we are good to go. Now, always remember the that you will store your file in a place where you can remember, and of course, you have to store it with a name that you can identify. So when you are trying to open it, you would not need to be going backward and forward. Now, this this space you will need to these icons are very important for you to highlight them. Sometimes they might be off, so you will need to highlight this the two space, the prospectus, your setting, the survey. Now, my my data, I am using the Congo data. So I'm using the Congo data. We have the Congo data and we have the survey data. So, but with the Congo data, I'll be working today. So let's um, let's go ahead. Let's import our points. You can either import create your import tools it from here, your point creation tools from here, or you create it from here. So let's create from here. Let's open it from here, and then you click on this. All right, so now you will need to import the file, and then you click on the plus button, and you know my my page is already on desktop, but for you, you might not find your page on desktop, so it is important that you know where you have stored it, and then you just navigate and try to get the location. So, and this is the name of the file I use. This is the name I used to store the file. So you click on it, and all right, so you can see it's clicked in green. And now remember I said we have our format in PENZD. So you have to look for PENZD. So this is PENZD, comma delimited. And so you can see the way the data are arranged, and then you keep it in that format. So you click OK. All right. You can't find the the points, but you can either go straight to this, or you type ZE and enter. So once I click on this, it comes up. So this is it. Now these are the points. Uh, on each of the points, you can see that there are no descriptions, and you may not be able to identify the various features on them. So you want to make it visible. So you click on one of it, and then select similar. Let me come again so that you'll see it. Click on one of it, and then you right click, and then you select similar. All right. So once you do that, you come to the properties and look for the point label star. Point label star. So this is the point label star, and then you are able to go here, and then for me, I want to know the sequence of the points taking, the elevation and the description. So I will click on this, and then voila. So that's it. You have all the information, but you can see that it's a bit clustered. So what you do is to come to the scale and reduce the scale. So okay, so now you can see them clearly. All right. So with this, we you would need to, for you to do a proper job, you will need to go through the points one after the other and check to know, these are just points, but each of those points have various features. Like now, if you look at this, these are junctions. This is a junction. Let me show it. Just can click PL, that's the polyline, and then you can link each of these points. Well, if you have a good surveyor, you all of these things he would have even done for you. Some surveyors will take their time to even plot and give you their own proposed center line and highlight all the features in it, where you have the fence, the buildings, and all the other features. You will see them clearly revealed. But if you don't have such things, you can as well take your time to indicate them. All right. So we will not be wasting time doing all of this. So I'll just go straight into the creation of the surface. So now we'll be creating the surface. Now we can, like I said, you can either work from the prospectus or you work from this workspace. Now, let's come here and create surface. All right. The points taken are existing ground level, and so you can name it as existing ground level or ground level, but I often name it as natural ground level. So N, make it N G L. All right. So then I want the style of my contour to be in one for the minor contours and at interval of five for my major contour. So that's why I'm going to choose contour in 1 meter and 5 meter design. All right. So you click OK. All right. So now you will come to this place and then come to the surface. Then you can see now you have the NGL opened. So you can click on the NGL and then come to definition and then you come to point group. Under the point group, you right click and click on add. Then you click on all points and apply and say okay. Now click on the surface and that's it. You have the contours for reviewed and you can see how the contours go. Now to further review the terrain of the road axis, you can try to put a number to it, like a reduced level. So what you do is to click on this and come to style. Here in the style, you click on the triangle. So you create a triangulation for you to link all of the points together and then you press OK. All right, so you can see how it is connected, how the points are connected. So now you come to annotate and click on add label, come to surface and come to contour multiple at interval. All right, so from here you try to create a line across the contours. So I'll try to, as much as possible, to make it cross through the contours. All right. Okay. All right. So you have to create like a benchmark, temporal benchmark. So just I'll make it as 100. Let's go for 100, and that's all right. So now you can see. All right. You can see. Let's see how it's graduating. This is a low level, which is 88. All right. This 87 is still going down. This 88 is coming up. 88 is on the plane. 88 on the plane. All right. 88. Now 89. It's graduating. Okay. Oh, this is 91. That means I have omitted one step, which should be 90. Okay, this is 90. All right. So that's it. You would it will give you a representation of the the ground and how it is graded. So, and with this, you are able to have a perspective of the flow of the runoff. You can as well use it for determining the runoff and determining the hydraulic capacity of your your drain or your culvert and so on and so on and so forth. So let's um, let's exit this. All right, you can you can off this and then apply. All right. So now we are going to be creating alignment. We're going to be creating an alignment, but before we create an alignment, you can see that the surveyor has actually tried to propose a center line for us. Now, it's important that we get to, the other time I said it's good that we understand the features of the road. Number one, if you're unable to go to the site to actually see the site, it will be very important for you to go through every single information sent to you by the surveyor, and that will help you in avoiding obstructions, avoiding permanent structures, buildings, and it will help to save the cost of the project. And as well, you have to identify the locations and the points of pipes, water pipes, gas pipes that are laid underground. So that when you are carrying out some excavation works, you will be able to avoid them in your design. So once you have a clear understanding of what your road looks like and the features, the landmarks that are on it, you are in a better position to avoid them. And where you cannot avoid them, you indicate that they have to be relocated. And of course, the right authorities will now be contacted for the relocation of these things. So, design of roads is not just to know how to design, but as well to understand the process, the methodology of construction, and all that is involved in the process. You have to design for economy and, of course, for stability. So, it's important that we put all these things in place. All right. So, having said that, I would like to use it might not be precisely the way the surveyor have proposed it, but at least it will be a guideline for us to create our own alignment. So in doing that, I want to isolate the center lines points alone, and then we can create our own alignment from it. So let's go to the prospectus and okay, you come to the point groups, and then you can see all points, but you don't have the center line. So what you do is right click and come to new. You have to create another point group, which is you now call it center line. All right, the center line. Now, if you come to the point list, there's nothing under the point list. So you have to come and include it in the raw description matching. So you come here and put CL, the center line is stored as CL, then you put a star, and then you can come here and then you can see. All right, so you can see that all the center line points have been listed here. So you can okay. So come back to this point, and now voila, you can see now it is here. So what you do is to